Hello guys, so this is David from Trivial Solutions IO here, and today I'll show a tutorial on how do I personally back up my entire laptop to S3 bucket so that I know if I lose my computer I can always restore it, and it's quite cheap. So I do it because I use ZFS on the root file system, and I use killer ZFS feature Snapshot. So I will not back up like my root partition because it's quite big. It's like it takes 70 gigs, so we will not wait that far. But I will create a separate data set just so that we could back this up in this entire video. So first things first, we'll create a data set. So as you can see, compression is off. This will be important later when we see if it's encrypted or not. And we will have key location specified. This will be encrypted data set. And my ZFS root partition is encrypted. If I turn my computer down, if it's off, nobody has access to it but me because I only have a passphrase. So let's create it with sudo. And I need to enter now a passphrase for my data set. So, in your case, this will be something strong. I just enter something quite weak here. And now we have our data set. And it's in a tank backup tutorial. So we can go there now. But, we can't touch any files, right? Because permission is denied. So what we need to do instead is we need to own our data set. So now it belongs to us, and if I touch file, then file exists and I will remove it now. So to have something to back up, we need to create a file. So we'll have a couple of 128 meg files. I will just print an encrypted header of the hello initial data set and get some data from urandom 128 megs, and we'll have our foo bin file. So now it contains our data. And now to back up something, you need to create snapshot in ZFS. So let's create a snapshot of this data set we just created. And now we have a snapshot, and now we can send this data set with ZFSN, but there's one critical thing to notice. If the data set that we have is encrypted, but if we just send it with ZFS and we grep through binary stream, we can grep our unencrypted string that we had here, like in foo bin. That's the head of this file, right? So obviously we don't want that. What we want to do is we want to send encrypted stream. So we need to add a raw flag. And now this sends raw encrypted blocks as they are in the disk, and nobody can read those. So if I grep the same hello here, I can grep this because it's not there, right? So now we have this state. So we can just back this up to S3. I will not go through how to set up S3 bucket and stuff. I have it prepared. You can back this up anywhere you want to NFS, other file system, decentralized file system. But I have this prepared command that I will send this raw data set, raw snapshot to AWS at this predefined location. And I will send this, and it should back up pretty quick. It's a small data set and I have a decent internet here. It's already done. And so now we can generate, we have only one file, we made a snapshot, we backed this up to S3, and we can restore this file from S3, right? So let's add another file. And this will be exactly the same thing, 128 megs, but this will be different wording here. Random data, right? So instead of hello, it's a world initial data set. And I will make a snapshot of this also. Now we call this at modified snapshot. And let's see the size of the modified snapshot in characters. So as we can see, it's now two files, both of them 128 megs roughly, right? So why is that? So we send also all the snapshots, all the blocks that go before modified. We send the entire state. Actually, we don't want to send the entire state. Why we use ZFS? Because we can have snapshots and just send their difference. So how do we send difference? We can specify in ZFS with -i flag that its initial send delta from initial snapshot to the modified snapshot, and let's see its size. So now the size is only 128 megs roughly, right? So obviously we want to send this and not the entire thing to S3, because we don't want to back up all the data from scratch all the time. It's wasteful. We can just send increments. And let's see that our increment only has data from the current data set. So we echoed word here, and this increment contains it, right? But for the initial file, our increment doesn't contain this. So if we grab hello now instead of world, this is the first file from the initial snapshot. This snapshot increment doesn't contain our string. So let's back this up. We back up our increment to S3 to the different file. Now it's initial to modified, right? You can think of any convention you want, just don't get lost across snapshots. Now we back this up to S3, and we should be good. We have our data backed up, right? So let's prove that we can get this data back from S3, right? So I'll copy from S3, from our backup tutorial, initial data set that we just backed up, and we'll receive it as a different data set. It will be tank/backup received instead of tank/backup tutorial that we just created. So let's receive this data set to the new place. And the thing is, we will not be able to cd into this directory right away, because we receive encrypted blob, right? We did not provide the decryption key for this dataset, so we will not be able to read from it just now. And we should receive, okay, we received our backup soon. And if we list it, we received our backup. It's 128 megs, but this directory doesn't exist. And why this doesn't exist is because our dataset is encrypted. We have to decrypt it, right, if we want to read files from it. So what we do, we just ask to load the key for this dataset. We enter the previous password with what we created this dataset, but it's still, we can't still go to the directory. Now we need to mount this directory because, well, it's a little manual step, but whatever. And now we have our same file, foo.bin. So if I check some foo.bin, and if I check some from the previous backup tutorial foo.bin, these are exactly the same files restored. Okay, so we can now just receive our data, our increment, to finish our backup cycle, to restore the modified file also. And if we try to do that now, we'll get, we should get an error maybe, I think. Oh yeah, we modified the current snapshot because this has file modification dates enabled, right? So we inadvertently modified this file. So what we need to do is now roll back to the pristine state of how we received this file, roll back our received snapshot, and we can do the same thing again. And now we should receive the rest of the data from S3. And that should be our entire backup restored. And let's wait a little bit. It shouldn't take too long. I also like to add a pipe pv command, so I'd see like a speed of how these operations are being performed. Okay, so we received our snapshot and we have the both files, and let's just double check that we indeed have the same exact hashes for both files and the backup tutorial. And we should have, yeah, so the backup snapshots are the same, and we restored our data we backed up from S3. And I now want to finish this video with the benefits, why you want to do ZFS snapshots and backups like that instead of what everyone else does. Usually it's rsync or you back up the entire partitions, which is wasteful. So first thing, you back up less data with compressions, right? Our ZFS snapshot was not compressed, but if I get like a compression from all my data sets, you can see that my root is compressed. Is it LZ4 or ZSTD? And if I get compress ratio, I back up less data. And sometimes, like for log, I back up 7 times less, right? Or on the ordinary root partition, I back up 32% less or so, right? So you back up less data because you use ZFS, which has compression. We didn't use that in that video, so we could manipulate like plain text and see the greps and etc. But you know, compression is there and you should use it. And we can also back up our encrypted data. So you know, we have our encrypted data set. It's AES 256 strong encryption, so we can use it to say back up to even a public storage where people would be malicious, say Filecoin, IPFS or other decentralized storage provider, and don't care because our data set is encrypted, well, assuming you encrypted with a strong password. And another thing, you back up only what's changed. You back up only what is changed. So as you can see, we send our increments from what actually changed in our huge data set. So how do I do this with my laptop? You know, I made initial backup of my laptop. It was like 300 gigs, right? And then after a month of usage, so say, you know, this snapshot, which one is it? Never mind. So this is our pool, NixOS, and I have this roughly a month later snapshot, and the difference between these is only 32 gig. And this was, I think, over 300 gigs or something like that. So initial snapshot was big, but you know, increment then is small, and then you can back these up on a monthly basis when you hammer the file system, and you just keep on going, make snapshot once in a while and backup increment, and you can replay any point, any month you backed up if you say corrupt your system, which doesn't usually happen for me because I use legendary NixOS. So yeah. Oh, you can't see it, NixOS, but you know, this is NixOS. Anyway, and another benefit is you don't need to shut down your file system, your laptop, to back up your stuff. So my root partition, right? My root, I can just make snapshot anytime I want. Making a snapshot works when I'm using my computer. So I make snapshot while I'm online. I don't have to shut down my laptop, and I can just send a snapshot to S3 while using my computer. Like, it's crazy. You couldn't do it with any XFS, ext4. Well, you might be able to do it with BTRFS, but you know. And this is much faster than rsync, right? So if I send this to dev null instead, it will be a lot faster. And PV, and let's go to dev null and let's see the throughput. So yeah, it's 1.28 gigs, right? So, or I can send a snapshot of some bigger snapshot so that we'd see like for real that it's a lot faster than sending rsyncs. And usually you will even not have, you will not be able to have your match internet provider. You back up a lot faster. So as you can see, it's 680 megs per second. Usually you don't have that much of a fast internet, right? So anyway, and the last one is, yeah, so I already mentioned this. You can back this up anywhere to decentralized storage, to, I don't know, to some equivalent to S3, to NFS. You can back up this anywhere else. You can redirect this pipe. This can be a file, this can be decentralized storage, this can be, you know, IPFS, this can be the same old S3, and etc. So yeah, so I hope this has been informational for you. This has been David from Trivial Solutions IO, and I'm signing out. Peace.